Hello and thank you for choosing Math Help, Jonas. We're going to solve a calculus problem that's typical of calculus 1 or 2 depending on the university. We're going to find a value k such that that integral that you're seeing there is worth 1. In order to solve this, we must be able to use direct substitution. You should be familiar with it, and also with some basic antiderivatives like integrating powers, for example. So let's get started. The first step would be taking that k out of the integral because it doesn't depend on the x, okay? You cannot do that with other parts of the integral, but the k is just a constant value. We can just put it out of the integral, okay, and just leave all the rest the same, including number 1. We just leave it like that. That k and that 1 will stay like that, and we're going to focus on solving just what we see on the parentheses. Okay, so let's get started with that. What do we do with that integral? The first thing is noticing that the derivative of logarithm is right there. Derivative of ln x is 1 over x, which is right here, dx over x. So what do? We make a change of variables. We're going to put u equals ln x. That's the first step. Now we're going to take derivatives because since we change the variable, we also have to change with respect to which variable we are integrating. And the derivative is quite simply 1 over x, but we can just write it like this. So that's what we get. U equals ln x, and du equals dx over x. That's what we're going to put in the new integral. But there is one step that we have to be careful with, which is changing the integration limits. We have that x equals 1, but we change the variable. Now u equals ln x. So we're going to get the extreme value of u by changing x by 1 in this substitution that we made. So u is ln of 1, which is 0 at this point. You should know that because the logarithm of 1 is 0 in just or in any base. If x equals e, that number, u equals ln of e. E is precisely the base of the natural logarithm, so the answer is 1. So now we got the two new limits of the function that now has u as its integration variable. So let's go ahead and write the new integral. So the new integral will have its limits 0 where there was 1 and 1 where there was e. And instead of ln x, we're going to get u. We know it's squared from the original function. And instead of dx over x, we just get du. And that's all we're supposed to integrate. To do that, we have to use the integration of a power. In this case, this becomes u cubed divided by 3. And now we're just supposed to evaluate in the integration limits, which we got, and they are 0 and 1. So we have just applied the integration of a power here. We added up 1 to this number 2. 2 plus 1 became 3, and we put that number 3 here too. So now we apply the fundamental theorem of calculus, and this becomes 1 cubed divided by 3 minus, again, this is not really that necessary if you're already familiar with this part of the process. You can be more direct and just realize this is quite simply 1/3. So now we have found the value. So we can just come back to the original exercise we had. This is what we had earlier. We found that everything in the parentheses is just 1/3. So we're just going to replace it. We're going to put here k times 1/3 equals 1. So we are ready to find the value of k, which is quite simply k equals 3. Now, of course, there is an interpretation a graphical interpretation we can give to this. So we can see here in green the function that we were integrating. Here it's plotted, and these vertical values are the limits of the original function. It was from 1 to e. Here it's an approximation of e 2.718. So this space here is the area we calculated in parentheses. We found a value k so that this area, instead of 1/3, became 1. So that's pretty much what we were doing. There is so much more. You probably have lots of questions. So go ahead and subscribe to keep getting more videos. Consider booking a private session that you will definitely benefit from. Bye for now. Thank you for watching, and the best of luck to you.